So let's look at the next one we have here, the local broadcast address. There's another address that we can't assign to end stations. Why is that? Because the local broadcast address is all 255s. Look at that, 255, 255, 255, 255, meaning that every single bit, all 32 bits are set to 1. 1, 1, 1, 1, 1, 1, 1. All right, I'll stop right there, okay? So 32 bits set to 1 equaling 255, 255, 255, 255. What is this address for? Well, this is your local broadcast address, meaning that if you are in your local area network and you want to talk to absolutely everybody, you send out your broadcast using that local broadcast of 255, 255, 255, 255. That's what you do. You send it out. I missed the PC at the bottom. Still missed it. There you go. So we send it out. It goes to absolutely everybody, right? Absolutely everybody in the local area network. Now, does the router forward it? That's the key to this. No. You see, what does it say here? It says the local broadcasts are going to be dropped by the router right here. Forget it. The router says, no. Right? This local broadcast is intended for the local area network. That's where we're going to keep that local broadcast on this side of my router interface. So as soon as the local broadcast arrives at the router interface, the router processes it because maybe it's intended for the router, but the router's not going to forward it on outside of the local area network. So an example of a local broadcast would be when a PC is trying to contact a DHCP server first thing in the morning, right? So the PC does not have a source IP address, does not know who the destination is, so it sends it to a destination of 255, 255, 255, 255, and says, hey, there's a DHCP server out there. Hook me up with some addressing information. What about when we're trying to figure out the MAC address of a device within our local area network, like our default gateway? Well, then we use an ARP request, and an ARP request destination goes to absolutely everybody as well. So we are sending to every single device in our local area network when we use this local broadcast address. Now, another address we cannot assign to our end stations is the loopback address. So anything that starts with 127, that's right, anything that starts with 127, we cannot assign to end stations in our organization because it's used for testing, local testing on the local device itself. So 127 is already reserved on the local device for local testing purposes, like checking to see if your TCP/IP stack is working properly. So if you pinged 127.0.0.1, and it's a successful ping, well, then that means your TCP/IP stack is working locally on your device. All zeros address can't give to anybody either. Why is that? Well, this all zeros address is reserved for any device that does not currently have an IP address, and we need to talk out on the network. So for example, if I'm trying to contact a DHCP server to get an IP address, well, I don't have an IP address. That's why I'm contacting a DHCP server. So the source of my packet that's going out is going to have all zeros, and the destination of the packet is going to be that local broadcast address. So the source of a DHCP discover message is all zeros right here, meaning I don't have an address. So I'm just going to use all zeros, and the destination is going to be that local broadcast address of all ones. So that way there we can find our DHCP server. So these are important IPv4 addresses to remember because you are not allowed to assign them to end stations or any other device in your organization because they're all reserved for a very specific purpose.